I guess we can start. So hi, my name is Hugo. I'm an independent Android developer at Little Robots and also a GDE for Android. And today we're going to talk about Nearby. And before we're going to talk about Nearby, there's a little demo app that I will show you, but you can also download it. And well, the Wi-Fi is a little bit flaky, so it might be challenging, but there are two ways to get it. I go to the bit.ly link. Maybe you have already seen a notification on your phone. You can't really open it because of my amateurism, but you can use the notification to download the app, or you can scan the QR code. So just wait a couple of seconds for everybody. Are you seeing it? Who is seeing the notification? Ah, cool. So that part works. Already a great success. Everybody got it? Okay. Yeah, so let's talk about Nearby. What's Nearby? So Nearby is a set of APIs that allows you to add proximity features to the app. And it's compatible with Android, and the messages part is also compatible with iOS. Yeah. So messages is one of the features, and messages allow you to publish and subscribe small pieces of data between devices. The other feature is notifications, is the one that you just saw on your phone, where you can send contextual notifications to Android devices that are nearby a certain beacon. And the third API is the connection API that allows you to connect Android devices in a peer-to-peer fashion without the need for network. So it's really offline networking basically. So let's first dive into the messages part. So like I said, it's on Android and iOS. It works on Android and iOS, which is convenient if you have an app that wants to share some piece of data between apps. You can think of, for example, sharing a little ID in your app for a video or some kind of item that you have in your app, and it allows you to share that to other apps. It's a publish and subscribe model, so your phone or a device, it's more a better term, will publish a message and other devices can subscribe to that. Ideally, this message that you send over is less than 3 kilobytes, but it can have a payload up to 100K. So how does this technically work? So on the left side we have a device, on the right side we have a device, and the left side wants to publish a message. What it's going to do is it's going to respond to my clicker. Yeah. It's going to send up the message payload, and it's going to generate a token and send it up to the Nearby API. So for this API, you do need networking. Without networking, it doesn't work. Then you have this relation on the Nearby API. Then it's going to emit the token of a Wi-Fi or Bluetooth, or even of audio, depending on the strategy. So if you use Wi-Fi or Bluetooth, then this message will probably carry around like 100 meters or so, because it's radio-based. If you opt into the earshot strategy, then it's only a couple of meters. So that's more for secret, is probably not the right word, but for messages that don't need to reach that far. That's where you can use it. And then they use like ultrasonic, near ultrasonic sound to broadcast this token. So this token will then eventually reach a device, and the device can then simply do a lookup with that token, and if the specific token that it has received is associated with the same API project, then the Nearby API will then return the message. So the actual message is not sent over in that broadcast, it's just a smaller token. Yeah, and that's how you basically share messages. So to set this up, you need an API project because it's using a Google API. This is quite similar to Google Maps, for example. You enable the Nearby Message API, and then you create an API key. And then you put that API key into your manifest, and you're basically good to go. I think Nearby is a pretty nice small API, and as of last year, they ripped out the parts that required you to juggle a Google API client, so that's convenient. You can now just get a client by calling nearby get messages client, and it's usually a good idea to keep a reference to that client, because you might have you can also configure it in different ways, and this will only give you the default configuration. And then it's pretty simple. You just have a payload, just a bunch of bytes basically, and you associate that with a message. And the message can also have a message type, which is convenient, so it can broadcast different kind of messages. And if you don't specify a type, it's having the default type, which is just the empty string. And then you just publish that message, and very important, also check if that actually worked. If you look at the Google examples, they will leave out the error checking part, but if you forget that, then you might get some strange results. Because it might fail, for example, when you don't have any network. So yeah, that's publishing. Receiving is equally simple. You have a message listener, which will give you a callback when a message is found, and also when a message is lost. So if the device is going out of range, or those kinds of situations. And then you subscribe with your message listener. You again add a failure listener and a success listener, and then once a message, any message associated with that project is being received, then you will get this callback. So when you run that code, it will the first time it will show a somewhat scary consent dialog saying, "Well, I'm trying to use Wi-Fi and Bluetooth and all kinds of other stuff." And this is for two reasons, because the Wi-Fi, this feature requires a fair amount of battery, so it's to inform your user that this is going to take a chunk out of your battery, but also because the users need to be aware that you're going to do this, of course. So the recommendation is to only invoke nearby on explicit user action. You can add some branding that they have put up on the developer side as well. And also take care not to share sensitive information, of course, because it can carry up to 100 meters around you. So I have a little demo of this. So this is, you can try it as well if you have the app now. So the first is a little, let's call it an emoji contest. And so it already works. So you can see, you select an emoji, and then you see what other emojis are nearby. So yeah, I'm not surprised that the pool one is scoring high. Exactly according to expectation, but so that's basically it. In this app, what it basically does is it generates messages of different types, so it's a unique message per device, because otherwise these messages would basically override each other. And then it's just a matter of receiving the messages and telling up the total count that it has received. So that's fun. Let's keep to it. Let's talk a bit about these things. Does everybody know what these are? Beacons, yes. So, just in case you don't know, what's a beacon? A beacon is a small Bluetooth device which sole purpose in life is to broadcast an ID and also some other info like transmitting power, so that you can figure out how far you are from this beacon. That's basically beacons in a nutshell. It can often also broadcast more stuff like the battery levels and temperatures or whatever. It kind of depends on the vendor. But for this context, it's important to know that there are two main standards: iBeacon, Eddystone. iBeacon is backed by Apple, Eddystone by Google. Eddystone is a little bit more open, has a couple of variations of standards. But these are the main two ones. And like I said, they're often used for coarse location. So if you want to know where you are at a certain place, in a store, in a museum, or somewhere in a place where GPS typically wouldn't really work, then it's often used for location-based stuff. But the beacon ID is basically a token, right? same kind of token that you can broadcast from a device. So what if we associate that token with a message again? Then we could send messages from beacons, basically. And that's exactly what the Proximity Beacon API and the Google Beacon platform let you do. They allow you to associate a beacon with multiple messages. And you can do that through an API, so you can do this all dynamically from your server, but you can also do it from the beacon dashboard. And I have a little example as well to show you how that looks. So let's take one of the beacons that I've set up. So you can see there's some information about the beacon. We can attach a place to it. We can say if it's supposed to move or not. So if you, for example, if you put this on a bus, it will probably be roving. So that the API knows what it's for, and you can add some arbitrary properties to it. What's interesting in this context is that we can also add a beacon attachment to it. And this is kind of boring, so let's change this. So this is my message type, and this is the data. So, and this is associated with my Google API project. So whenever my app sees this particular message, then it will, it can use that, basically. What's also cool about the beacon dashboard that it doesn't necessarily need to work with your beacons. This is a project in Amsterdam where this is a Google project called Amsterdam Open Beacon Network, so it's just an API project. But this is shared with whoever wants to use this. And if I click on beacons that are published here, you see that this stuff is all read-only because I'm not the owner of these beacons. So again, this is somewhere in Amsterdam. And I can also not see the attachments, but I can still add my own attachments, which basically means that I now have the possibility to write an app that, if I'm nearby some kind of bus stop in Amsterdam, can receive a message from the beacons that are deployed around Amsterdam. So I think that's a pretty cool feature. So so what I've shown, you can set beacon statuses. You can take them online and offline, which doesn't really turn off the beacon, but just removes the association. And you can add attachments for different projects onto different beacons. So you have a kind of shared infrastructure. And let's say you have something like a treasure hunt. You could have a treasure hunt. Once you see a beacon, you get this message, and then you send to your server that I collected this treasure. The server could then, through the beacon API, update the beacon again to change the message and basically take away the treasure. So this, I think, is pretty nice infrastructure. So when you're using nearby, we could use the same flow as we have for the emojis. So I could have beacons also emit emojis, and you'll also have the same opt-in. So from the API side, it looks totally the same. But the other option is that you also can subscribe to beacon messages only. So let's say you want to make use of that Amsterdam network. We'll just subscribe to beacons only. We don't care about phones. And then you can also scan in the background. And background in this context means that it can scan once the screen is turned on. So it will basically, that's basically provided by Google Play services in this case. If you're in the foreground, if your app's in the foreground, then you get also callbacks for distance and signal strength. So usually you use the signal strength and the transmitting power to figure out how far you are from this beacon. But you can, can get them both. If you have other uses for that, you can triangulate yourself if you want to. And setting up that is pretty much the same thing, but now we're specifying some extra things in the client. In particular, that we set permissions, set up permissions only to use BLE, so Bluetooth. And then the subscription, we pass in a strategy of BLE only, and we have to make sure that we have the location permission, the Bluetooth permission, of course, And also that location is enabled, especially if you're on Android 6 or up. That's a requirement from the Bluetooth API. If you don't have location enabled, you can have all the permissions that you want, but you still are not finding any beacons. And the message listener basically looks the same. One thing to, something that's a little bit different. In the on-found, you might get public messages. So if you are using shared infrastructure, an owner can set an attachment to public, but all these messages are namespace, so you can check by the namespace if this is a public message or if it's one of your own. And then there are 2 additional callbacks for the signal change and the distance change, and it will give you an approximate distance in meters to the beacon. It's not super accurate, but it's usually good enough for approximation of the distance. Like I said, you can subscribe in the background as well. And this setup looks pretty much the same except for the pending intent. So you switch out your message listener for a pending intent. And you can have up to 5 pending intents listening to beacons in the background that way. And otherwise it's pretty much the same. You still set the strategy and you add the on-video listener to figure out if you reach that limit or if something else goes wrong. And then in your receiver, you pass the intent that the nearby API will give you back to the nearby API itself, and you pass in the same message listener, and that will generate callbacks on your receiver, basically. A third option is, if you don't care about the Google Beacon platform, you say, well, this is all proprietary stuff, I don't want to use it. You can still scan for beacons, so you can use this in your own apps. If you want to use your own registry, for example, you can set up a filter to listen for particular proximity UIDs if you're using iBeacons, or add a stone namespace. But in this way, you are only limited to a maximum of 5 of these IDs, of course, due to the pending intent limit. And then in the message callback, you can get the beacon ID that you've encountered back from some utility class that they're providing. Okay, well, let's see. Looks super. So a super simple demo of this is the beacon message. So this beacon takes some time to start up. And if all goes well, so this was basically the thing that I just set up in the browser. I changed the text here. So this one, dumb linking. So this does need network, so all goes well. Yeah, I guess network is failing me. Maybe someone sees it. Okay, trust me, this works. Did I save this? Yes. Yeah. Okay, so yeah, first failed demo. Anyways, what you should have seen is this message that I set on the beacon, and currently it only shows the default message. Okay. This is fine. So, on to notifications. Notifications is basically a way to show contextual notifications on your Android device, and it's based on beacons as well. So the idea is that you can have the user see an URL or a deep link to an app, like the ones that I already published. In my case, the deep link doesn't work, but that's because there's something wrong in my Android manifest. But yeah, that's how you can set it up. And you can also do things like, if the app is installed, show this message, or if the app is not installed, show this message, that kind of stuff. It's, of course, incredibly important that these notifications are relevant to the user. So they also heavily proxied and filtered them based on relevance and rank and all kinds of stuff. And they have been tweaking that over the past years. In effect, it's a special kind of attachment set by the beacon owners, which sort of raises the interesting question: how do you prove that you own a beacon? Because a beacon signal is somewhat by definition pretty public. Anyone can pick it up and then say, well, this is my beacon, Google beacon platform, this is my beacon, and then you can do things with it. So what if I, for example, register a large portion of beacons at a national airport? Schiphol has 2,000 of these things deployed around the airport, and I fly once in a while, and I noticed that they're not registered. So in 2016, around Christmas, I finally thought of something to do with these beacons. And if you were at Christmas around Schiphol Airport, you might have seen this notification. And if you clicked on that, you would first see some onboarding from nearby. And if you then still click on it, then you will see my Christmas message, basically. So this, of course, this is quite funny, but I could have tried to send other messages, which are not that funny. I like this. People actually tweeted out this stuff to me. So yeah, it was kind of exciting, but also sad. I don't know. Yeah. So how did I set it up? You can target all these notifications based on language. So I had a lot of languages there, and some I had the whole page translated, and some I had only an English page with a localized message. For beacon owners, though, this was somewhat the point I was trying to prove. I had like a quarter of their beacons registered to me. So it's a good idea if you're deploying a lot of beacons, please register them with the Google platform, because otherwise anyone can basically take over your beacons in that sense. And if you do, then also remember that the Google Beacon platform is basically vendor agnostic. If you buy Estimate beacons and then later you change your mind and buy them from some other vendor, it's just fine. It's all iBeacons, it's all Eddystone, and Google Beacon platform doesn't really care. Usually when you buy beacons from a vendor, there's also a software platform to manage them, and SDKs from that vendor. So it's more of a vendor lock-in game in that sense. If you have these beacons registered, why not share them with developers, or at least share them with your third-party trusted parties for all kinds of stuff. I know they are actually doing that at Schiphol, but then with trusted partners and a proprietary platform. And this all still works with the existing SDKs or platform OS scanning. So yeah, register these beacons, please. If you're an owner, no, don't go out and register any beacon, only your own beacons. So there's also another way to do this. Most beacons have a secure ID feature, which basically means that I change the ID once in a while. But that's really vendor specific, so you really need the SDK, and yeah, I really prefer the other way. Okay, so let's talk a little bit about connections. Connections allow you to connect devices in a peer-to-peer fashion, so without any network this time, and it uses Bluetooth and Wi-Fi. I think it's a pretty interesting API because, yeah, there might be some offline scenarios like multiplayer games on planes, I don't know, that kind of stuff. So yeah, in theory, so you don't need any set connection to use this. It used to be different though. In the previous API, you need some kind of network. But now you can pick a couple of topologies. You can say, well, I want to have a one-to-many connection, which is P2P star. You can go for P2P cluster, which means any device can connect to any device. And we can have a one-to-one connection. For the connection API, there's no particular setup. There's no API key because it's not an online API. But you do need to declare the proper permissions in your manifest. So in particular, you use Bluetooth and Wi-Fi. And again, if you're using Bluetooth on Android 6 and up, you also need the location permission, and I think you also need location enabled. If you use the other nearby messages API, it will just turn on whatever it needs. But for connections, I don't think that's the case. And there are a couple of steps that your app needs to go through. So, of course, you have to advertise that you are able to take connections, and another party needs to discover any advertising devices. And then, at some point, you'll find the device and will request a connection, and then both parties will get a connection request, and in that request there will also be a shared auth token. And that gives you the opportunity to show something to the user. Is this the correct device that you want to connect to? If it is the correct device, or you just don't care about the auth token, you just accept the connection. You can also reject the connection, of course. And after you've set up that, you can send payloads. There are a couple of different payloads. You can set raw bytes. We can also send over files, for example. Or you can have a stream of things, like somewhat like a file, but just without a specified length. So this is what advertising looks. You need to have a connection callback. And basically, when the connection comes in, you'll see you get an endpoint, which is sort of an identifier for your other side. And you get the connection info, which tells you something about, which also has this auth token and has some other info. And then, so you either check if this is the correct device, or you just say, well, accept this connection, and yeah. And then you pass in a payload callback to handle the actual payloads. The connection result will eventually be called when the connection is really established, and will either say it's successful or not. So it has a fancy connection result thing, but there are basically two outcomes. And if a disconnection happens, you also get a callback of that. API is pretty similar, so you get the connections client, and then you start advertising. The first argument here is a human readable name of the device. If you can't come up with a human readable name, then you just paste in an empty string and it will generate one for you. The second argument is a service ID. So that's basically the unique identifier for your application, or your, whatever you have. If you have multiple services in your app, then you can broadcast multiple services, of course. In this case, I just have the application ID, and you pass in the connection callback. And you also pass in the strategy that you want to use. In this case, P2P cluster, so this is a many-to-many connection. And again, it's very important here. All these calls return a task object, Google Play Services task object. And in the documentation, they sort of slip a slide and don't really show you that you always should check the errors, because especially on the connection stuff might go wrong and you want to handle these errors. Otherwise, you're just pulling your hair out, seeing why it doesn't advertise, broadcast, find something. Because it's also dealing with Bluetooth, and Bluetooth is not particularly super stable on Android, or that kind of stuff. So if we have something advertising, then we also need a way to discover it. Same thing, you have a callback for discovery, gets you an endpoint ID, and also some extra info like the human readable name and the service that it found. Endpoint loss is similar to the messages. When it goes out of range, it's no longer found, then we'll just tell you that as well. And then you can start your discovery. Again, you pass in the service ID. You pass in your callback, and you need to have the same strategy for finding the advertising side of this. And once you have found a device, then you can decide to connect to it. And this is how you do it. So you request connection. Again, the empty string means make up some human readable name, give it the endpoint and the connection callback, which is the same similar one that is shown before. And again, it's also important here that you add the failure listener, because, for example, especially in the peer-to-peer one, a connection might already be in progress and will tell you, oh, you're already connecting to this thing or someone. Yeah. So do check those errors. And eventually, you want to transfer some data, and this is the payload callback. If you're doing byte transfers, this is a little bit simpler. There's a maximum size that you can transfer. It's about, I think it's 32K at this point. But every time you receive a payload, it will have a particular type. So it might be bytes, might be a file, or it might be a stream. In the case of bytes, you're done here. You just check the payload. It's a byte array, you use it. If it's a file, you need to hold on to it somewhere, because eventually you will get a payload transfer update telling you either that this payload, this transfer is still in progress and how much the progress is, or if it's finished. If it's finished, then you know that you can use the file. And the same goes for the stream. And this goes both ways. So if you're sending something, then also you'll get updates for the stuff that you are sending. So eventually we want to disconnect. There are a couple of options. You can disconnect from a single device and keep on advertising, discovering, and that kind of stuff. But usually you just want to stop discovery, stop advertising. And there's the stop all endpoints that will basically make sure that from that point you can't take any new connections and you can't really connect to anything else unless you do a new discovery or new advertising. Okay. Let's show another demo. Well, this doesn't rely on network, but it should work. Though it does rely on Bluetooth, so you never know. So, what I have here is a little app that shows some confetti on one device. And if we're lucky, it takes some time to form the connection, but it should start connecting. There we go. The idea is that every device that receives a confetti message basically relays that to other devices that are connected. Come on. Yeah. Oh, here we go. Someone is connected. It's not one of my devices, so someone is seeing confetti on this device here. Yeah, very cool. It works. Oh, yeah, this one is also connected now, so yeah. So this is like, it's basically scanning for any device, right? And it puts up to 2 connections now, and it's totally random to what it connects to. So it doesn't necessarily need to be my devices. And we can see how many are connected here. So I have 2 on this, 1 on that. So advancing discovery, and this middle one is probably a little bit stuck. Yeah, so if I, yeah. So yeah, apparently that one is not connected to this one. So that's kind of interesting. That's yeah, so confetti is super cool. Can you now impress your friends with this? So if you like confetti as much as I do, there's a lib that I use from a fellow Dutchman called confetti. It's written in Kotlin, obviously, because it starts with a K. Yeah, some remarks on the connections API. When it works, it's pretty awesome, I think, because it feels a little bit like magic connecting to all the devices without any network. But it seems to be a little bit hit or miss, mostly due to Bluetooth issues. Although it seems to be worse when you're developing because you're just killing the app underneath Google Play services, and then people will say, well, what's going on? I'm not sure what's happening, and then the next time you try to do this Bluetooth connection, it fails. It's very important that you check for errors. I had a couple of issues where it's already advertising, and you need to keep some state about, am I connected or not? If you forget to do the error handling, then yeah, you will screw that up, basically. Another tip is to basically stop discovering and or advertising before you start connecting, because in general this is a pretty heavy operation on the Bluetooth stack to do the discovery, and yeah, it might interfere with the connection. So you might get better results when you stop discovery and just start the discovery after you're connected again. Yeah, so a little bit fast, but anyways. Conclusion, I think it's small and concise API, especially the messages part is interesting to me. Hopefully there will be more beacon network kind of things showing up, which developers then can use. Because yeah, who is going to deploy, I don't know, a couple of thousand beacons on their own? If we have some more coverage, or yeah, I know on the Amsterdam Beacon project there are some apps that allow you to do like a virtual city tour, for example. I think that's a good use of beacon infrastructure that's already there, and it doesn't interfere basically with the stuff where the beacons are meant for, depending on their use case, of course. So the notifications, I can see the use case. We're at a place or we're at some kind of, for example, a movie theater or something. You want to see the program that says, hey, I have this app where you can check it. But yeah, on the other hand, it's also very low-key, so you really need to know that's there. So I'd say, yeah, keep on experimenting with it, and if you own beacons, please make sure that you register before somebody else does. Yeah, and the connections, I think it's really nice, really powerful. It's not always reliable, so I hope that they will improve that a little bit in the future. And it probably comes with new devices as well, where the Bluetooth stability is getting better. Also, if you're using, for example, the P2P star option, then it uses Wi-Fi. It seems to be a little bit better, but it really depends on what kind of solution you're building with this P2P stuff. Yeah, and that's all I have on nearby for now. It's good. If you have any questions, I'm happy to take them.
You mentioned there is two popular standards of beacons, right? Are they comparable? Or like, let's say if you have both types, do you need to have like two clients or something?
Yeah, so the question is, there are two popular standards, iBeacon and Eddystone. Are they compatible? They are not compatible. So the difference is basically what they are broadcasting and how you take that broadcast. So they are not compatible from the protocol standard, but if you use something like the Google Beacon platform, it will happily take any of these beacons, and then you're only dealing with messages. So then you can receive messages from either beacons. It doesn't really matter, because when you look in the platform, there's no real mention of this is an iBeacon or this is an Eddystone. It just has a beacon ID, and based on whether it's iBeacon or something else, it has a slightly different ID.
So they basically work together only through the network, like through the internet, right?
Yeah, they work together in that sense. They all broadcast an ID, and you basically attach your messages to these unique IDs. And if you're using Eddystone, for example, in the Eddystone specification, there's also an encrypted kind of broadcast, and that's also supported by the Google Beacon platform, so it can figure out which beacon you're actually. So it's both encrypted and also, you can use any beacon basically. And I think that's the strong part for this platform, because let's say you have tons of iBeacons and at some point all the batteries drain out and you need to replace them or whatever, you decide to go to another vendor. You're not really stuck to a particular vendor of beacon hardware. Yeah.
I'm not sure if I understood correctly. One of your recommendations was that it helps to advertise on discovery before you connect, right?
Yeah.
How does that lend itself to the fact that we have strategies many to many? Like if you stop advertising, if a device stops advertising, how can then accept additional basic connections?
Yes, so the question was, I said it's a good idea to stop advertising or discovery once you start connecting. I think once you stop advertising and other devices already have seen your app, it can still initiate a connection. So it doesn't stop accepting. So that still works. For discovery, of course, it doesn't really matter, because that only means that you're slower into connecting to other apps, because you can't really, depends on your strategy. So in this app, I'll just do, when I find something, I try to connect to it and stop the advertising. But you could also collect every device around, wait for, I don't know, a couple of seconds, and then say, well, I have 5 devices, let's try now in a row, something like But stopping the advertisements shouldn't really stop getting income connections for that. So that should still work. Yeah. And it kind of varies. I think there are also devices which cannot simultaneously discover and advertise. So you have to figure that out. It's also important, again, it's important to check the error codes for that because it will tell you if that's the case. Yeah. Other questions? Yes?
It's about the connection. So you told us it works between Android devices. What is missing for the iOS part? I mean, globally, other hardware vendors.
Yeah. So the question, if I understand correctly, why doesn't it work on iOS? Yeah. Because the main reason is that to make these connections happen, there's a lot of low-level platform stuff. So it's messing with Bluetooth basically. So it's turning your device into an advertiser, or in the case if you do P2P start, will turn on a Wi-Fi hotspot. And I don't think these features are available on Apple to apps. So yeah, Google obviously has a little bit more possibilities to Google Play services to do this stuff. So it's basically a platform restriction, I guess. Yeah. Anyone else? All right, thank you.